Today we're going to learn how a simple high-pass filter works using a resistor and a capacitor. So first we're going to see what's the theory behind it, how you can create a simple circuit, and we'll run a simulation at the end. So we can make a very simple high-pass filter using a AC voltage source. So in this case we're using a 10 volt, a resistor, which is we're using here 1 kilo ohm, and a capacitor, 1 microfarad capacitor we're using. We are connecting them in series, and for high pass filter we have to consider that the output we have to collect is from the resistor. For low pass filter you have to collect the output from the capacitor. So how it works? So the key is the capacitor, function of the capacitor. So if we just look back our definition of frequency, which is 1 over time, and the angular velocity, which is 2 pi over t, and then if we combine these two equations we can get 2 pi f. So the speed depends on the frequency. Now if we look at the definition of impedance of the capacitor that has a fixed capacitance C, and if we plug the definition, Z equals to 1 over omega C, and if we plug the value of omega here, then we can tell that the impedance of the capacitor depends on the frequency as inversely proportional. That means the impedance of the capacitor decreases as the frequency increases, and also we can say the impedance of the capacitor increases if the frequency decreases. So this combination makes it possible for the voltage across the resistor to be equal to the voltage to the source depending on the high or low frequency. And we're going to see in a simulation in a little bit. So let's see how the voltage is divided. So if we apply the voltage divider rule, and assuming this is the capacitor has a resistance or impedance of Z, so the voltage divider rule, the voltage across the capacitor will be the source voltage multiplied by the ratio of the resistance or impedance of the capacitor over total resistance. And since the impedance depends on the frequency, that means higher frequency will give you lower voltage drop. So if we have enough higher frequency of the input voltage, for example 20,000, what will happen is that the voltage drop across the capacitor will be almost zero, and the voltage drop across the VR, across the resistance, will be almost equal to the input voltage. And since the output will be taken across, you see the prong here, if the output is taken across this resistor, then we'll get a high pass filter. So only the high frequency will be when the frequency is very high, we'll get signal, almost equal signal on the resistor. And this is how the high pass filter works. So a high frequency causes a low voltage drop across the capacitor and high voltage drop across the resistor. And the low frequency causes a high voltage drop across the capacitor and low voltage drop across the resistor. So if you have a very low frequency, say example 10 Hz, 20 Hz, then the high voltage drop will be across the capacitor, and then the voltage drop across the resistor will be very low. And since we're tapping across the resistor, we'll not get any low frequency passing through. So this is how it works as a high pass filter. Now we're going to run a simulation in a Multisim where we're going to see the voltage changing across the capacitor and resistor. The green line will show the voltage across the capacitor, and then the blue will show the voltage across the resistor. So let's do the simulation in Multisim. So I have created a simple high pass filter where I have a voltage source 10 volts, and initially I put a 20,000 Hertz. I put a capacitor 1 microfarad, and I put a resistance which is 1 kilo ohm, and I'm reading the voltage. So I went here and then I was reading the voltage across the capacitor and the resistance. So when the frequency is 20 Hz, let's run and see what's happening. So if we see the graph, if we stop it and then zoom in, and let's do a half and half plot. So, and I'll reduce this. So now you can see when the frequency is very high, the voltage drop across the green one, capacitor, is very low. And then the voltage drop across the resistance is almost equal to the 10 volt, which is the source voltage. If we take the output voltage in series with the resistor, then we'll get, for high frequency, we'll get the signal out from the resistor. And this is how it is working as high pass filter. So what happens if we reduce the frequency very low, say 200 or 20, say 220 hertz? If we run the signal again, the circuit, and if we stop and want to see how it looks like, so now you see the voltage drop across the capacitor for low frequency is almost as the source voltage, and then the voltage drop, the blue one, across the resistor is almost nearly zero. So for low frequency, I'm not getting any voltage out, or very low, almost zero voltage out from the resistor. And this is how this filter is acting as a high pass filter. When you have a low frequency, you will not get any output across the resistor, but only you have high frequency, you will get full voltage drop across the resistor, and this is how it works as a high pass filter.